Good morning, students. My name is Amit and I welcome you all to Grade 7 GD Goenka Public School, Kanpur. In this very first video tutorial, I'll be teaching you guys all little tips and tricks that you need to know about number system. So, let us start by first understanding what a number system is. A number system is defined as a system of writing or expressing numbers. It is mathematical notation for representing numbers of a given set by using digits or other symbols. In earlier days, when there were no means of counting, people used to count with help of fingers, stones, pebbles, etc. But these methods were not adequate and had many limitations. Now, to overcome these limitations, many number systems were introduced. In any number system, a value of digit can be determined by using the digits. For example, number 189. 1, 8 and 9 are the digits. The second thing that you must understand here is what is the position of the digits. By position I mean units place, tenth place, hundredth place and so on. The third and most important thing about number system is the base of the number system. Okay, now since you know a number system is set of values used to represent different quantities, let us study its types. There are various types of number systems in mathematics. The four most common type of number systems are decimal number system, binary number system, octal number system and a hexadecimal number system. So, after knowing the number system types, let's explore these number systems in detail. The first number system that I'm going to be telling you about is decimal number system. The word decimal here comes from the word deci, which means 10. That is why this number system is also called as base 10 number system. Decimal number system has base 10 because it uses 10 digits 0 to 9 and they are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. In decimal number system, the position successive to the left of the decimal point represents units, tens, hundreds, thousands and so on. The quantities that you count here are represented as 1075 and negative 1275 and 3500 and so on. These number system can also be written inside the small bracket as you see down on the last line here, 1075 inside the small brackets with base as a 10. The base is written down just like this. Okay, wasn't that easy enough? So let's move further to the next number system, which is called as binary number system. The binary number system is also called as base 2 number system because it has only two digits, that is 0 and 1. Specifically in this system we represent quantities which are in combinations of zeros and ones only. For example, 110101 is a binary number. The quantities in this number system are always represented as inside the small brackets 110101 with the base as 2. The computer system that we use or the laptop that you have right in front of you right now, it uses binary number system. Okay. The third number system that we have here is called as octal number system. The word octal here comes from a geometrical figure you might have heard of, octagon. Octagon is basically a polygon which has 8 sides, and that is why this number system is also called as base 8 number system. In octal number system, the base is 8. That means it uses 8 digits for counting and representing quantities, and these digits are 0, 1, 2, 3, 4, 5, 6 and 7. We don't have 8 and 9 here. The quantities here are represented as 215 with the base as 8, or inside the small bracket you can write 215 with base 8 outside the brackets. The last number system that we have here is called as hexadecimal number system. We have already seen decimal number system before. A decimal number system consists of 10 digits, and hexa here means 6. So together we have 10 plus 6 as 16, and this number system has 16 digits. That is why this is also called as base 16 number system. In hexadecimal number system, numbers or quantities are written or represented by a base 16. The digits here are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like we had in decimal number system. And after that we have A, which represents 10, B, which represents 11, C, D, E and F that represents 15. For example, 12AF3 with base 16, or you can also write it as 12AF3 inside the small brackets, and outside the bracket you write the base 16. Okay? Okay. So, after studying all these number system, let's do some arithmetic. The first conversion is decimal to binary. The process is quite simple. All you need to know is the table of 2. Take the number 14. Now, divide this number 14 by the base, which is 2. When you divide 14 by 2, you get 7 as quotient and 0 as remainder. Write the remainder on the right hand side, and quotient, which is 7, right under 14. Now process is to be repeated. Again, take the number 7, divide it by 2, you get 2 3 times 6 and remainder is 1. So write the remainder on the right hand side, and 3, which is quotient, right under 7. Again repeat the step. Take the number 3, divide this number 3 by 2. When you divide, you get 1 as a remainder and 1 as a quotient. Remember, quotient is to be written right under 3 and remainder 1 on the right hand side. Now read these numbers from down to top. So you have 1 1 1 and 0, and this is equivalent of number 14. Okay, so the next conversion that we need to learn is decimal to octal. Now we have already seen decimal to binary conversion. In decimal to binary conversion, we were dividing the number by 2. Now the base has changed. We have 147 decimal. We need to convert that decimal number into octal, and octal number system has base 8. So we need to divide 147 by 8 instead of 2. Okay, so 147, when you divide by 8, you get 18 as quotient and 3 as remainder. 18, 8 times is 144. So you get 3 as a remainder, which is to be written on the right hand side, and quotient 18 right under 147. Repeat the same steps. Divide the number 18 by 8. 8 2 times is 16. Now you get 2 as a remainder and 2 as a quotient. Quotient you have to write right under 18 and remainder on the right hand side. Now read the numbers from down to top. You have 223. Now this 223 of octal number system is equal to 147 of decimal. Yes, the next conversion is decimal to hexadecimal. In previous examples, we have seen how to convert a decimal number to binary and decimal number to octal conversion. When we were doing decimal to binary, we were dividing the number by 2, and when we were doing decimal to octal conversion, we were dividing the number by 8. Now, in this example, we need to convert a decimal number into its hexadecimal equivalent. Remember, the hexadecimal number system has a base 16. So in this process of conversion, we need to divide 1309 by the base, which is 16. So take that number 1309 divided by 16. I suppose all of you are having paper and pen with you, right? So do the division. Yes. Now when you divide 1309 by 16, you get 81 as quotient and 13 as remainder. 81 times is 1296. So when you subtract 1296 from 1309, you get 13 as a difference, which is the remainder. Now take the number again. Which number? 81. Take the number 81 and divide it by 16 again. Now 16 5 times is 80, and when you subtract 80 from 81, you get 1 as a difference, which is remainder. Write that remainder on the right hand side, and 5, which is quotient, right under 81. Now read the number from down to top. We have 5, 1 and 13. You need to remember one small thing, that in decimal number system we have 13, but in hexadecimal number system we don't have 13. So instead of 13, we have to write its equivalent hexadecimal number. Remember, 10 is represented as A, 11 is represented as B, 12 is represented as C, and 13 is represented as D, 14 is represented as E, and 15 is represented as F. So now we have 5, 1 and D. The number 51D is equal to 1309 of decimal number. Hope you have understood this. In my next video, I'll be teaching you guys some reverse conversion, binary to decimal, octal to decimal, and hexadecimal to decimal, along with binary addition, binary subtraction, binary multiplication, and binary division. Till then, keep revising this. Stay safe, stay home. Bye bye.